Okay, so let's go ahead and take a look at this 1-4 assignment. So the first thing we start off with is rewriting the expression so we don't have an absolute value, which is what we did last year in a previous class. And what we're looking at doing is we're looking at whether or not the inside of the absolute value is always positive or always negative. If it's always positive, then we just drop the absolute value bars. If it's always negative, then we have to take what's inside that absolute value and multiply by -1. So is pi minus 2 always positive or always negative? Well, it is always positive because 3.14159 minus 2 gives me a positive number. So all I get is pi minus 2. Now, if I were to get an always negative number, I would have had to take what's inside the absolute value and multiply by -1. That's how I rewrite this without absolute value. Okay. Now, I do want to graph absolute value equations. So when I go and I graph absolute value, what I would do is, first step is to set what's inside the absolute value equal to 0 and solve for x. And so when I do that, I get x is equal to 3. Then what I'm going to do is I'm going to pick two numbers for x that are smaller than 3 and two numbers that are bigger than 3. So I pick two smaller, so 2 and 1, and I pick two bigger, which are 4 and 5. And then I plug it into my absolute value equation here in for x, and then I solve. So when I plug in 3, I get 0, so then I get 4. When I plug in 2, I get absolute value -1, which is +1, times 2, which is 2, plus 4, which gives me 6. When I plug in 1, I get 2 times 2, which is 4, so I get 8. And then I plug in 4, I'm going to get 6. And then I plug in 5 in for x, and I get 8. So then I'm going to go ahead and I'm going to draw my graph here. Anytime you don't know what you're doing as far as graphing is concerned, just pick some values, and then try to figure out what's going on from there. Okay, so I have 1, 2, 3, 4, 5. At 3, I'm at 4. At 1, I'm at 6. Sorry, at 2, I'm at 6. At 4, I'm at 6. And then at 1, I'm at 8. And at 5, I'm at 8. So I get, remember our absolute value graphs are V-shaped graphs. Okay, so I'm going to write this as a piecewise function. And the way that I do this is I take each part separately. So I'm going to take this part of the graph first, and I'm going to write the equation of that line. It's got a slope of -2. Now let's be clear. The way I'm going to write this as a piecewise function is I'm looking at, to the left of this, what we call the vertex. And so what it is all of these values give me a negative inside my absolute value. So going back to what we did with question 1. When I plug in 2, I get a negative value inside the absolute value. So what I'm going to do is to write my piecewise function is I have my 2, and then I'm essentially dropping the absolute value, multiplying what's in the inside by -1, and then adding 4. Okay, and this is if x is less than or equal to 3. Now I have bigger than 3. And remember, with bigger than 3, all the values of x that I'm plugging in are all bigger than, are all greater than 3. So inside the absolute value, that'll always be positive. So I have 2 times x minus 3 plus 4 if x is bigger than 3. Now, where I put the equal bar, it doesn't matter. I could have put it with the top equation. I could have put it with the bottom equation. Doesn't matter. So you could have a different answer from somebody next to you because it depends on where you put the equal bar. It doesn't matter. You do have to put the equal bar. Otherwise, if you didn't put the equal bar, then this vertex would be an open circle. So just pick one to go ahead and put the equal bar underneath. And then I get f of x is equal to, this will be negative 2 times x minus 3 plus 4. And I'm just cleaning it up a little bit. Just so that way we didn't have double parentheses. And then this is if x is less than or equal to 3, if x is bigger than 3. Or I could have rewritten this as f of x. I could have chosen the other one to have the equal bar. So I could have chosen if x is less than 3, and then 2 times x minus 3 plus 4. If x is bigger than or equal to 3. So where I put that equal bar doesn't actually make any difference whatsoever. Okay? Do the exact same thing for question 5 here. We're going to graph and write this as a piecewise function. So again, I set what's inside my absolute value equal to 0, and I solve for x. So in this case, I get 1. When I plug in 1 in here, into my equation, I get 1. Now I'm going to pick two numbers that are smaller than 1 and two numbers that are bigger than 1. So I'll pick 0 and negative 1, and then I'll pick 2 and 3. When I plug in 0 in here, I get 0, so I get a negative 1, and then plus 1, so I get 0. And then when I plug in negative 1 into my equation, I get negative 2. Absolute value negative 2 is 2 times the negative 1, which is negative 2, plus 1, which is negative 1. And then I do the same thing with 2. I plug in 2, and I'm going to get 0. And then I plug in 3, and I get negative 1. And you will start to see a pattern when you graph these. And so if you see the pattern, you can just fill in the table real quick and not have to worry about, showing a bunch of arithmetic. No calculators, so you do want to do all your arithmetic in your head. You won't use calculators in this class for a really long time. Okay, and then again, I want to write it as a piecewise function, so then I look and when I have values of x that are smaller than 1 here, that means I have a negative. I'll drop the absolute value and get a negative, and then plus 1 if x is less than, and I'll put the equal bar on the first one. I always put the equal bar with the first one just so that I don't forget the equal bar on one of them. Okay, and then bigger than that, so then I drop the absolute value, so I have negative x minus 1 plus 1 if x is bigger than 1. So overall, I get x minus 1 plus 1. And you could simplify this more if you really wanted to. But when we do open-ended questions on a quiz or on a test, if you simplify and you simplify incorrectly, you get the problem wrong. If you leave it unsimplified and it's right unsimplified, then you get it marked correct. So just be a little careful. Okay. Question 7 is to write the equation of the graph. So the first thing I'm going to do is I'm going to find the vertex. So the vertex is 1, 3. And I'm going to plug this into the general form for absolute value x minus 1 plus 3. Remember that your general form is a times x minus x1, plus y1, where x1, y1 is your vertex. Okay, so now I'm going to go ahead and, in order to solve for a, which is that number in front of the absolute value, I'm going to use the coordinate point 5, 4. So I will always have a little coordinate point that's matched, or that's marked there. And so I'm going to plug that in. So I have 4 is equal to a times 5 minus 1 plus 3. So 4 is equal to a times the absolute value of 4 plus 3. So 4 is equal to 4a plus 3. Subtract 3 from both sides of your equation, so you get 1 is equal to 4a, so a is equal to 1/4. And then I plug this back into my general form, so 1/4 absolute value x minus 1 plus 3. Okay, so that's how you write the equation of the graph that's given. And we have another one here, just another practice question here. So we'll look at number 9. Again, find my vertex, which is -1, -3. So y is equal to a times x minus a -1 minus 3. So y is equal to a times x plus 1 minus 3. I use my coordinate point here, which is 1, -4. So -4 is equal to a times 1 plus 1 plus 3. So -4 is equal to 2a plus 3. Sorry, minus 3. I changed it to plus for some reason. Minus 3, so that I add 3 to both sides, and I get -1 is equal to 2a, so a is equal to, -1/2. So y is equal to -1/2, absolute value, x plus 1, and then minus 3. Okay, and that gives you all of the odd questions for this particular section.